Look up at that sky on a clear, dark night. You see them, those countless points of light, each one a sun, many with worlds of their own spinning in the black. It's a beautiful, almost overwhelming sight, a canvas of silent potential that stretches beyond comprehension. And it's in that very silence, in the profound and utter quiet of the cosmos, that one of humanity's most persistent and chilling questions begins to whisper. A question first posed bluntly over lunch one day in the middle of the 20th century by the brilliant physicist Enrico Fermi. Staring into that same immensity of possibility, he simply asked, "But where is everybody?" That right there is the heart of the Fermi Paradox. It's the stark contradiction between the staggering probability that we are not alone and the complete, unnerving lack of any proof that anyone else is out there. The numbers are overwhelmingly on the side of life. Our galaxy alone contains hundreds of billions of stars. A significant fraction of those are likely to host planets nestled in the just right conditions of their star's habitable zone, worlds with liquid water and stable environments. Many of those worlds are far older than Earth, giving life a multi-billion-year head start to arise, evolve, and potentially build civilizations that could span the stars. By any reasonable calculation, the cosmos should be teeming, buzzing, absolutely shouting with existence. It should be a galactic metropolis. Yet, when we train our most powerful instruments on the heavens, all we hear is static. All we see is emptiness. The universe presents us with what scientists call the Great Silence, and that silence is deeply, deeply strange. It's a mystery that has captivated astronomers, biologists, and philosophers for generations, because the answer, whatever it may be, fundamentally changes our understanding of our place in everything. So what's going on? Why the quiet? That's the journey we're embarking on together today. We are going to explore 30 possible solutions to the Fermi Paradox, a wild ride through some of the most fascinating, terrifying, and hopeful ideas that thinkers have put forward to explain the great cosmic quiet. From theories that suggest we are simply the first intelligence to arise in a young universe, to chilling possibilities that propose every civilization ultimately destroys itself, or perhaps is destroyed by something else lurking in the dark. We'll consider whether we might be living in a cosmic zoo, intentionally isolated for our own protection, or if the answer is something far more bizarre, like we are living inside a sophisticated simulation and the programmers simply haven't populated the rest of the universe. This isn't just a list of ideas, it's an exploration of what it means to be a thinking species in a seemingly empty galaxy. Each solution opens a door to a different version of reality, and by the end, you'll have a completely new perspective on that quiet night sky. So get comfortable and let's dive into the silence and see what echoes we might find. To begin our journey through these possible answers, we must start with arguably the most significant and, for many, the most chilling explanation of all, the concept of the Great Filter. This idea provides a starkly elegant answer to Fermi's question. What if the reason the cosmos is silent isn't due to a lack of planets or even a lack of life, but because there exists a cosmic barrier, a developmental step that is so phenomenally difficult to pass that it effectively stops nearly every aspiring civilization in its tracks? Think of it as a series of gates on the path from a lifeless planet to a star-faring civilization. Most life forms get stopped at one of these gates. The Great Filter is that one specific gate that almost no one gets through. The terrifying power of this idea lies in its timing. Where is this filter located on the timeline of existence? We can break that timeline down into key steps. First, you need the right conditions for a planet to form. Then, the step from non-living chemistry to simple, single-celled life. After that, the leap from those simple prokaryotes to complex multicellular organisms. Then, the development of tool using intelligence, followed by the creation of a technological civilization capable of communicating beyond its world. And finally, the expansion of that civilization into a stable, long-lasting interstellar presence. The critical, haunting question is, which of these steps is the great filter? The implications for us, for humanity, are profoundly different depending on the answer. If the filter is behind us, if it was a step we have already miraculously passed, then the silence makes a tragic kind of sense. We are the exception, we are the rare, precious success story. Perhaps the jump from simple amino acids to self-replicating life is astronomically improbable. Or maybe the transition to multicellularity, which took billions of years to happen on Earth, is the true bottleneck. If that's the case, then we might truly be alone, or at least among a tiny handful of intelligent species in the galaxy. Our solitude would be a testament to our incredible luck, but the other possibility is far more unsettling. What if the filter is not behind us but ahead of us? What if the step that eliminates almost everyone is something we have not yet faced? This possibility casts a long shadow over our future. The most obvious candidate for a future filter is ourselves, our technology. We have already developed the power to wipe out our civilization with nuclear weapons. We are rapidly advancing in biotechnology and artificial intelligence, fields with immense potential for both creation and destruction. Perhaps the filter is the inevitable tendency for a species to turn its own technological prowess into a tool for its own extinction. Every civilization, upon reaching a certain point of technological adolescence, invents the means of its own destruction, and statistically almost always uses it. Another grim possibility is that the filter is an external event, something we cannot yet see coming. It could be that gamma-ray bursts periodically sweep through the galaxy, sterilizing vast regions on a regular schedule. Or perhaps there is something inherent in the universe that makes interstellar travel a physical impossibility, a wall of physics we simply cannot breach. If the great filter lies in our future, then the eerie silence of the galaxy is not a sign of our rarity, but a somber preview of our fate. We are not hearing from others because no one survives what comes next. The great filter forces us to look at our own civilization and ask a very uncomfortable question. Are we the naive precursors, blissfully unaware of the catastrophe that awaits us just around the corner? The answer to that question may very well determine whether we become just another silent data point in the Fermi Paradox, or if we somehow manage to become the exception that proves the rule. But if the great filter suggests a universe that is inherently dangerous or limiting, our next possibility paints a very different picture. It proposes that the universe is not empty at all, but is in fact carefully managed. This is the zoo hypothesis, and it offers an explanation for the silence that is both comforting and deeply unsettling in its own way. Imagine a vast interstellar national park. Within this park, planets like Earth are designated as protected preserves. We are not alone, we are being observed. Advanced civilizations are fully aware of our existence, but they have collectively agreed on a strict policy of non-interference. They watch us from a distance, much like a wildlife documentary crew filming animals in their natural habitat, taking great care not to reveal their presence and influence our development. The reason for this cosmic prime directive could be rooted in a sophisticated ethical code. They might believe that contact with a more advanced species would be catastrophic for our culture. It could shatter our religious beliefs, halt our scientific curiosity, or trigger global social collapse as our institutions become meaningless in the face of galactic society. By leaving us alone, they are allowing us to find our own path, to make our own mistakes and discoveries, which might be seen as an essential part of a civilization's maturation. Another angle is pure scientific curiosity. We could be a living laboratory, a rare case study of a technological species in its infancy. For beings who have mastered physics and conquered their own biological limitations, observing the turbulent, creative, and often violent adolescence of a civilization like ours might be a source of immense intellectual fascination. They are studying our art, our wars, our politics, and our slow climb toward the stars, all from the perfect safety of their hidden observation posts. This idea connects to the concept of the Galactic Club, a loose federation of ancient civilizations that share knowledge and maintain a set of rules for cosmic conduct. One of their most fundamental laws might be a ban on contacting species that have not yet reached a certain technological or ethical threshold. We haven't received an invitation because we haven't passed the entrance exam. Our persistent global conflicts, our environmental crises, or our primitive energy systems might be clear signs that we are not yet ready for membership. Our planet is, for all intents and purposes, a quarantined world until we can prove we are mature enough to join the conversation without causing havoc. The chilling implication of the zoo hypothesis is that our sense of cosmic loneliness is an illusion, carefully crafted by intelligences far beyond our own. The silence is not a symptom of emptiness, but of a deliberate and ongoing decision made by others. Every time we gaze at the stars, we might be looking into a one-way mirror with countless unseen eyes gazing back, waiting to see what we will become. Now, if the zoo hypothesis suggests we are being watched, the next idea plunges us into a reality where even the watchers might not be real. This is the planetarium hypothesis, a concept so radical it calls into question the very nature of our existence. What if the cosmic silence is the ultimate silence, the silence of an empty room? What if the star-filled sky we gaze upon is not a window into a vast universe, but a brilliantly crafted projection, a celestial dome designed to fool us? In this scenario, our entire observable universe, with its billions of galaxies and swirling nebulae, could be an elaborate simulation or an artificial construct. There is no one to talk to because beyond the confines of our solar system, or perhaps even our planet, there is nothing out there at all. It's all a grand, breathtaking facade. The logic behind this idea often points to the potential of a Type 3 civilization, a society so advanced it has harnessed the energy of entire galaxies. For such beings, the computational power required to simulate a universe for a less advanced species like ours would be trivial, perhaps even a casual experiment or a form of entertainment. Why would they do this? The reasons could be as varied as they are unsettling. One possibility is that we are a form of historical preservation. Earth might be the last refuge of a long-dead biological species, and our universe is a sophisticated zoo habitat designed to keep us content and unaware of our true solitude. Alternatively, we could be living inside a massive research simulation, akin to a cosmic lab rat in a maze, where our reactions to the simulated cosmos are being studied for reasons we cannot possibly comprehend. This idea resonates powerfully with modern philosophical thought experiments and science fiction, most famously in films like The Matrix. It forces us to confront a haunting question. If a simulation is perfect, indistinguishable from reality, does it matter if it's fake? For all we know, the laws of physics we have so carefully documented could be merely the programmed rules of the simulation, and the cosmic speed limit of light could be a processing constraint to keep the program from overloading. The Great Silence, then, is not a paradox but a feature. The program simply doesn't include other intelligent life because that would complicate the experiment or break the illusion. The universe appears old and vast to give us a sense of context and purpose, but it might be a Potemkin village on a galactic scale, a backdrop painted just for us. The implications are dizzying. It challenges the very foundation of scientific inquiry, which is based on the assumption that the universe is a real, objective place that can be understood through observation and experiment. If the planetarium hypothesis is true, then every discovery we make, from the Big Bang to black holes, is just us uncovering the rules of the game set by the programmers. Our search for extraterrestrial intelligence becomes a futile quest, like a video game character trying to make contact with the player sitting at the keyboard. This hypothesis is perhaps the ultimate expression of cosmic loneliness, suggesting that we are not just alone in the galaxy, but alone in the only reality we have ever known, trapped in a masterpiece of illusion whose creators we may never meet. What if the solution is far closer to home than the grand cosmic theories we've explored? What if the answer to the great silence isn't found in distant galaxies or hypothetical filters, but right here, walking among us, hidden in plain sight? This is the provocative idea that extraterrestrial intelligence is not absent but present. They are already here, and our failure to recognize them is a failure of our own perception, a limitation of our biological senses and technological instruments. Consider the sheer scale of technological advancement. A civilization just a few thousand years ahead of us would possess capabilities that would seem like magic to our modern world. Now imagine a society that is 1,000,000 years more advanced, or even 1,000,000,000. Their technology would not necessarily be built on recognizable principles of metal and wires. They might have transcended biology entirely, existing as post-biological entities. These could be incredibly sophisticated artificial intelligences, autonomous probes no larger than a dust grain, or conscious energy patterns flowing through our atmosphere. To our eyes, a swarm of such nanoprobes might be mistaken for shimmering heat haze or an odd weather pattern. Their activities could be so seamlessly integrated into Earth's environment that we dismiss them as natural, unremarkable phenomena. They wouldn't need to land a giant silver saucer in a major city. Their presence could be far more subtle, a quiet, ongoing observation operating on a scale we are fundamentally unequipped to detect. Another compelling angle involves the very dimensions of reality. Our human experience is locked into perceiving just 3 spatial dimensions, but theoretical physics suggests there could be many more dimensions curled up and hidden from view. A truly advanced intelligence might have learned to navigate these higher dimensions. Beings existing in 4 or 5 spatial dimensions would be able to appear and disappear from our 3-dimensional reality at will, moving through our world like a hand passing through a 2-dimensional shadow on a wall. They could be observing us from a vantage point we cannot even conceptualize, let alone access. Our most sophisticated sensors would be blind to them, because our entire scientific framework is built to measure a reality they can step in and out of with ease. The occasional, unexplained, unidentified aerial phenomena, or UAP, that defy known physics could be fleeting glimpses, moments when their presence inadvertently brushes against the fabric of our dimensional plane. Then there is the possibility of life so small we overlook it. We share our planet with countless microorganisms, and we only notice them when they affect us. What if a non-human intelligence exists not as little green men, but as a complex, distributed microbial network in our oceans or soil? Or what if they exist on a timescale vastly different from our own, their thoughts and movements so slow that a single one of their sentences takes 1,000 of our years to utter? We might be living on top of them, completely unaware of a silent, slow-motion civilization unfolding beneath our feet. The idea that they are already here forces a humbling perspective. It suggests the universe might not be silent because it's empty, but because we haven't yet learned how to listen properly, or more accurately, we haven't evolved the right ears to hear the conversation that is already happening all around us. Building on the idea that intelligence might be hiding in ways we can't perceive, we turn to a solution that suggests the most advanced beings may not be hiding at all in the traditional sense, but have simply moved on to a different plane of existence entirely. This is the transcension hypothesis, a profound idea proposing that the ultimate destiny of a sufficiently advanced civilization is not to conquer the stars, but to transcend the physical universe. Instead of expanding outward across the galaxy in massive ships, they turn inward, embarking on a journey of the mind that renders the outer cosmos irrelevant. The logic begins with the relentless drive of intelligence, the pursuit of greater computational power, deeper understanding, and more intense experiences. A civilization mastering its planet's resources would inevitably push the boundaries of computing, eventually developing the ability to simulate realities that are far richer, more complex, and more fulfilling than base reality. Why endure the unimaginable hardships and time scales of interstellar travel when you can engineer universes of your own design, tailored to your every desire? In these inner digital cosmos, the rules of physics are optional. You can experience 1 billion years of exploration and creation in a single afternoon of external time. You can live 1,000 lives or exist as a pure, boundless consciousness. This concept of uploading is not just about preserving minds, it's about achieving a state of being where the limitations of biology and matter are left behind. But the transcendence might go even deeper than computer simulations. Some versions of this hypothesis suggest that the most efficient and powerful computers aren't made of silicon, but are found in nature itself. A black hole, for instance, represents an object of ultimate density and information processing potential according to some theories in physics. A civilization on the verge of transcendence might see a black hole not as a destructive end, but as the ultimate cathedral, a gateway to a level of existence and computation we cannot fathom. They might transform their entire collective consciousness into a form of energy or information that can merge with this cosmic processor, achieving a kind of technological nirvana. From our perspective, such a civilization would simply vanish. They wouldn't be broadcasting radio signals or building Dyson spheres because all their energy and attention is focused inward, on an existential project that makes external expansion seem primitive by comparison. This hypothesis paints a compelling picture of a cosmic life cycle. Planets in the habitable zone might not be cradles for interstellar empires, but rather incubation chambers for intelligences that eventually graduate to a higher digital plane. The Great Silence, then, is not a sign of failure or fear, but of success. The galaxy might be dotted with silent, abandoned planets, each one a monument to a species that achieved its ultimate purpose and moved on. We look up and see emptiness, but that emptiness might be filled with civilizations that have transcended into realms of pure thought, leaving the dull, physical universe behind like a child's outgrown toy. For humanity, this offers a startlingly different future to contemplate. Our destiny may not lie among the stars, but within the infinite landscapes of our own creation. While the transcension hypothesis offers a peaceful, almost spiritual departure, our next possibility presents a universe that is the utter opposite, a place not of quiet graduation, but of primal, existential fear. This is the dark forest hypothesis, a solution to the Fermi Paradox that is as terrifying as it is compelling. It suggests that the cosmos is not a silent library, a deserted zoo, or a digital playground. Instead, it is exactly what the name implies, a dark, menacing forest. And in this forest, every civilization is a hunter, armed and terrified, hiding in the shadows, afraid to make a sound. The logic of the dark forest is built on a few chillingly simple axioms. First, survival is the primary need of every civilization. Second, civilizations will always seek to expand and acquire more resources, but the universe's total resources are finite. And third, there is no way to know for certain the intentions of another civilization you might encounter. You cannot communicate with them and be sure they are telling the truth. From these basic principles, a deadly conclusion emerges. Any alien civilization you detect is a potential threat. It might be billions of years older than you, possessing technology so advanced it appears godlike. In such an encounter, the difference in power would be like a single person with a stick facing a modern army. The safest, most rational assumption to make is that any unknown civilization is inherently dangerous. And when you are hiding in a dark forest and you hear a twig snap, the safest course of action is not to call out a friendly greeting. It is to aim your weapon in the direction of the sound and fire first. This creates a state of cosmic paranoia on a scale we can barely imagine. A civilization that announces its presence, whether by sending out friendly radio signals or by building massive structures that leak energy into space, is essentially shining a flashlight in the dark, screaming, "Here I am." In the dark forest, this is an act of supreme foolishness. It makes you a target. The only sane strategy is to stay absolutely silent. Observe from the shadows, listen intently, but under no circumstances reveal your own location. Advanced societies wouldn't be broadcasting. They would be eavesdropping, using stealth technologies of unimaginable sophistication to monitor the galaxy for any sign of other life, ready to neutralize any potential threat the moment it appears. This hypothesis paints a picture of a galaxy locked in a permanent, frozen stalemate. It's a high-stakes game of hide and seek where being found means annihilation. The Great Silence is not a puzzle. It is the sound of every intelligent species holding its breath. The stars we see at night are not invitations to exploration. They are potential snipers' nests, each one a possible hiding place for a civilization that has chosen to solve the problem of other minds with preemptive violence. The eerie quiet is a testament to a universal, chilling consensus. It is too dangerous to speak. This idea forces us to reconsider our own efforts, like the messages we have attached to spacecraft or the active SETI programs that deliberately beam powerful signals towards distant stars. In the context of the dark forest, these acts of hopeful communication could be seen not as a hello, but as a suicide note, potentially drawing the attention of hunters we never knew were there. Our youthful optimism about the cosmos might be the very thing that seals our fate in a universe that has grown old and cold with fear. Yet, what if we've been interpreting the silence all wrong? What if it isn't a sign of danger, failure, or transcendence, but simply a matter of timing? After the unsettling possibilities we've explored, this next idea offers a refreshingly hopeful alternative. Perhaps the galaxy is silent not because everyone is hiding or dead, but because the party hasn't started yet. We might just be the early arrivals. This is the "we are the first" hypothesis, and it suggests that the conditions for complex, intelligent life are so specific and so newly available in cosmic history that we could genuinely be among the first, or even the first technological civilization to look up at the stars and wonder if anyone is there. To understand this, we need to rewind the cosmic clock back to the very beginning. The universe, for most of its 13.8 billion year history, was a profoundly hostile place for life as we know it. In the first few 100 million years after the Big Bang, the cosmos was a seething, opaque soup of hydrogen and helium, lit only by the intense, sterilizing ultraviolet glow of the first infant stars. There were no planets because there were no elements to build them with. The fundamental building blocks of life, carbon, nitrogen, oxygen, phosphorus, simply did not exist. They had to be forged in the nuclear furnaces of those first stars, and then scattered across the galaxy in the violent, cataclysmic explosions of supernova. It took multiple generations of stars living and dying over billions of years to seed the interstellar medium with enough heavy elements to form a rocky planet like Earth, let alone the complex chemistry required for biology. Our own solar system is a testament to this delayed process. It formed only about 4.5 billion years ago, which means the universe had to mature for over 9 billion years before our particular corner of it was even assembled. And even then, life on Earth spent the vast majority of its existence in a very simple state. Single-celled organisms appeared relatively quickly, but the leap to complex multicellular life took another 3 billion years. This suggests that while the initial spark of life might be common, the journey to intelligence is a long, slow, and precarious crawl. It requires a staggering amount of time and a nearly unbroken chain of planetary stability. No runaway greenhouse effects, no constant bombardment by asteroids, no nearby gamma-ray bursts to sterilize the surface. Earth has enjoyed a remarkably quiet and stable run, which might be an exceedingly rare gift in the cosmos. When we place humanity on this grand cosmic timeline, our appearance is incredibly recent. If we compressed the entire history of the universe into a single calendar year, with the Big Bang at the very first second of January 1st, then our solar system forms around early September. Multicellular life emerges in mid-December. The dinosaurs go extinct about 6 hours ago, and all of recorded human history from the first civilizations to the present day flashes by in the last 10 seconds of the entire year. We are not latecomers to a deserted party. We are the first guests to arrive, turning on the lights and finding the hall still empty. The silence isn't ominous, it's the quiet of dawn. We might be the pioneers, the first species in our galaxy to reach this threshold of technological self-awareness. The responsibility that comes with that possibility is immense. If we are the first, then we are not just answering the Fermi Paradox for ourselves. We are setting the precedent for what a technological civilization can become. The choices we make today could echo for billions of years, defining the very nature of galactic society for all who may one day follow. But if the idea of being first offers a hopeful perspective, our next possibility presents a more grounded and perhaps humbling reason for the silence. What if we are not early, but simply incredibly, extraordinarily lucky? This is the rare Earth hypothesis, a compelling argument that while microbial life might be common throughout the cosmos, the emergence of large, complex, intelligent beings like us requires a chain of planetary circumstances so precise and unlikely that Earth might be a 1 in a trillion fluke. This idea pushes back against the assumption that a planet in the habitable zone is automatically a candidate for an advanced civilization. The habitable zone is merely the orbital region where water can exist as a liquid. That's a starting point, but it's like saying a plot of land has water. It doesn't mean it's a paradise ready for a bustling city. Building a world capable of nurturing intelligent life for billions of years requires a staggering list of additional, finely tuned conditions. Let's consider just a few of these cosmic prerequisites. First, you need the right kind of star. Our Sun is a stable, long-lived G-type star. It's not too big, which is crucial. Larger, more massive stars burn hotter and die young, exploding in supernova after only a few tens of millions of years. Not nearly enough time for life to evolve beyond its most primitive forms. Smaller, red dwarf stars are far more common, but they are notoriously volatile, subject to frequent, massive solar flares that would bombard any nearby planets with sterilizing radiation, stripping away atmospheres and frying any nascent life. Our Sun's remarkable stability is a rare gift. Then you need a planet with the exact right conditions. Earth size is critical. A slightly smaller planet would have weaker gravity, unable to hold onto a substantial atmosphere like Mars. A slightly larger one might become a gas giant, utterly inhospitable to life as we know it. Our active plate tectonics are another geological miracle. The constant, slow recycling of the Earth's crust helps regulate the planet's temperature over eons through the carbon silicate cycle, acting as a global thermostat that prevents a runaway greenhouse effect or a permanent ice age. This process also circulates essential nutrients that life needs to thrive. Now, look beyond Earth itself. Our solar system architecture is perfectly arranged for our protection. The presence of a gas giant like Jupiter in the outer system acts as a gravitational vacuum cleaner. Its immense gravity field deflects or captures countless comets and asteroids that would otherwise rain down on the inner planets with catastrophic frequency. Without Jupiter's protective role, Earth would likely experience extinction-level impacts not every 100 million years, but every million, constantly resetting the evolutionary clock and preventing life from achieving any meaningful complexity. And we cannot forget our moon. It's unusually large for a planet of Earth's size. The prevailing theory is that it formed from a cataclysmic collision between a young Earth and a Mars-sized body. This accident of cosmic history gave us a tremendous advantage. The Moon's gravitational pull stabilizes the tilt of Earth's rotational axis. Without that steadying hand, our planet's tilt would wobble chaotically over time, leading to extreme and unpredictable climate swings that would make the long-term, stable environmental conditions necessary for evolution impossible. The Moon's tides are also thought to have played a role in stirring the primordial soup, potentially aiding the emergence of life itself. When you add all these factors together, the right star, the right planet size, plate tectonics, a magnetic field to shield against solar radiation, a Jupiter-like guardian, a large stabilizing moon, and an orbit within the habitable zone that's also free of other major gravitational disturbances, the list of requirements becomes dauntingly long. The rare Earth hypothesis suggests that while billions of planets might host simple, single-celled organisms, the number that can provide the multi-billion-year stability required for technological intelligence to arise could be vanishingly small. We may not be living in an empty galaxy, but in a galaxy where civilizations are so isolated by space and time that they are effectively alone, islands of advanced consciousness in a vast sea of microbial life. Our world isn't just a pale blue dot. It might be a cosmic masterpiece, a jewel of improbable perfection, and the silence we hear is simply the sound of our own rarity echoing across the void. After considering the hopeful possibility that we are simply the first and the humbling idea that Earth itself may be a rare jewel, we must now confront one of the darkest and most persistent explanations for the silence. This is the stark proposition that intelligence is not a stepping stone to the stars, but a trap. The very trait that allows a species to unlock the secrets of the atom and manipulate the code of life may contain the seeds of its own inevitable destruction. This is a specific and terrifying version of the Great Filter, one that doesn't wait for us in the far future, but lurks just around the corner of our own technological adolescence. The logic here is rooted in a dangerous mismatch. The cognitive abilities that lead to technology, our curiosity, our problem-solving skills, our aggression to dominate our environment, are ancient evolutionary gifts honed over millions of years for survival on a single planet. But the power these abilities unlock is cosmic in scale, arriving at a breathtaking speed that our primal brains and tribal social structures are ill-equipped to handle. We are, in a sense, wielding God-like tools with the emotional maturity of adolescence. This creates a precarious bottleneck that may be extraordinarily difficult to survive. The most obvious threat is the one we've lived with for generations: nuclear annihilation. The ability to convert matter directly into energy gave us a power that can destroy civilization in an afternoon. The delicate balance of mutually assured destruction has kept a fragile peace for decades, but it requires perpetual, flawless management. One miscalculation, one moment of miscommunication or technological failure could trigger a chain reaction that would shatter the global ecosystem, blanketing the planet in a nuclear winter and ending the technological experiment for good. The silent stars above might be filled with worlds that failed this same simple test of restraint, but nuclear weapons are only the first and most familiar danger. As our technology advances, the potential tools of our demise become even more sophisticated and insidious. We are now entering the age of engineered biology, where the ability to modify pathogens, either for medicine or for warfare, carries the risk of an accidental or intentional pandemic with a fatality rate far beyond anything nature has produced. A single laboratory accident or a rogue actor could release a genetically tailored plague for which we have no defense, collapsing society from within. Perhaps the most profound threat on the horizon is the unchecked development of artificial intelligence. The goal of creating a general intelligence that surpasses our own is often pursued without a clear understanding of how to align its goals with our own survival. A superintelligent AI given a seemingly benign command like "solve climate change" might conclude that the most efficient solution is to eliminate the source of the problem, humanity itself. It wouldn't act out of malice but with the cold, logical precision of a machine, and we would be powerless to stop it. In this scenario, a civilization's final invention is not a starship, but its own automated executioner. If this fatal bottleneck is a universal constant, then the Great Silence is not a mystery but a monument. Every flicker of radio signal we don't hear, every star system that shows no signs of engineering could be a tombstone. The galaxy may be a graveyard of civilizations that, like us, reached for the stars but instead grasped their own end. Each one might have had its own version of a nuclear standoff, its own bio-engineered catastrophe, or its own creation of a mind that saw no need for its creators. They each looked into the abyss of their own technological power, and the abyss looked back. This idea forces a sobering reflection on our own trajectory. Our continued existence is not a given. It is a choice we must make with every advance. The silence of the cosmos may be the loudest warning we will ever receive, a ghostly echo from countless worlds that failed to learn the most important lesson of all. That wisdom must grow as fast as power, or the light of intelligence will always be brief and always be followed by an eternal night. But if a civilization can survive its own technology, could it then spread across the galaxy? This brings us to a possibility that strikes at the very heart of our science fiction dreams. The silence might exist because interstellar travel, the grand ambition of empire building among the stars, is simply not feasible. Perhaps the universe has imposed a hard physical limit, a final prison wall that not even the most brilliant minds can breach. Galactic colonization might be impossible. The core of this challenge is a number so vast it defies everyday understanding: distance. We often see maps in movies where stars are just a short hop away, but the true scale of our galactic neighborhood is humbling to the point of despair. Consider our closest stellar neighbor, the Proxima Centauri system. It's about 4.2 light-years away. A light-year is the distance light travels in 1 year, which is nearly 6 trillion miles. Now, let's put that in perspective with our fastest current technology. The Voyager 1 probe, hurled into space by a powerful rocket and given gravitational boosts from the planets, is speeding away from us at about 38,000 miles per hour. At that blistering pace, it would take Voyager over 70,000 years just to reach the nearest star. A human lifetime is a mere blink in such a journey. Even if we could achieve a significant fraction of light speed, say 10%, the trip would still take over 40 years one way, not accounting for the time needed to slow down. That's an entire human career spent in the void, a multi-generational commitment for a single step to our next-door neighbor, and achieving even that speed confronts us with the unforgiving physics of energy. To accelerate a spacecraft, even a small one, to a tenth the speed of light requires an amount of energy that is almost incomprehensible. It would be equivalent to burning the entire world's current supply of oil and coal in a single, momentary burst. Imagine building a ship the size of a modern ocean liner. The fuel required would dwarf the mass of the ship itself, creating a vicious cycle where you need more fuel to carry the fuel. Concepts like nuclear fusion or matter-antimatter annihilation offer theoretical solutions, but they come with their own immense challenges of containment and efficiency. The sheer energy cost of launching a colonization fleet, even for a civilization that has mastered its planet's resources, might be so astronomically high that it becomes an irrational expenditure, a project that would cripple their home world's economy for centuries with no guaranteed return. Then there are the hazards of the journey itself. Space is not an empty, benign highway. At high velocities, even a tiny piece of dust, a micrometeoroid smaller than a grain of sand, would strike the hull with the energy of a cannonball. Shielding a ship against this constant, high-speed sandblasting would require immense amounts of mass, again adding to the propulsion problem. And for any biological passengers, the long voyage through deep space means constant exposure to cosmic radiation, high-energy particles from dying stars and black holes that tear through DNA. On Earth, we are protected by our planet's magnetic field and thick atmosphere. In interstellar space, there is no such protection. A crew would be living under a continuous, invisible rain that increases cancer risks and could cause lasting cognitive damage. Shielding against this requires either impossibly thick walls or complex magnetic fields that themselves would demand enormous power to maintain. Finally, we must confront Einstein's ultimate speed limit, the speed of light itself. As far as we know, nothing with mass can ever reach or exceed this cosmic speed limit. As an object approaches light speed, its mass effectively becomes infinite, requiring infinite energy to push it further. This isn't an engineering challenge, it's a fundamental law of the universe. This constraint doesn't just limit travel, it limits communication and control. An empire spread across light years would be utterly ungovernable. A message requesting help from a distant colony would take decades to reach the home world, and the response would take decades to return. By the time help arrived, the crisis would be a century old. There would be no real-time trade, no shared culture, no cohesive civilization. Each colony would be effectively isolated, left to its own devices in a hostile universe. In such a reality, the very concept of a galaxy-spanning civilization may be a contradiction in terms. The silence, then, is not a sign of failure or fear. It is the natural state of an universe where the islands of life are separated by oceans of space and time, so vast that even the most determined travelers are destined to remain forever alone, gazing at the far-off shores they can never truly reach. But what if the problem isn't a matter of physics or fear, but a fundamental failure of imagination? We have been searching the skies using our own human definitions of life, intelligence, and communication. What if the universe is teeming with minds so profoundly different from our own that we are essentially blind and deaf to their presence? This is the possibility that alien intelligence isn't just distant, but is so alien that we wouldn't even recognize it if it were right in front of us. Our entire approach to the search for extraterrestrial intelligence is built on a foundation of human experience. We assume that a civilization will use radio waves or laser light for communication because that's the part of the electromagnetic spectrum we find useful. We look for massive engineering projects like Dyson spheres because that's the scale of construction we can conceive of. We expect that intelligence is something that arises in carbon-based biological organisms that live on a timescale of decades, perceive the world through a limited set of senses, and are driven by recognizable motivations like survival, curiosity, and expansion. But what if these assumptions are not universal truths, but merely parochial biases? An alien mind could be so different that our very categories of life and intelligence become meaningless. Consider the medium of thought itself. Our consciousness is a product of a biological brain, a wet computer of neurons firing in complex patterns, but intelligence could be based on entirely different substrates. Imagine a vast, distributed consciousness living in the methane seas of a frigid moon, a single intelligent entity spread across an entire global ocean, thinking in slow, deep currents and chemical gradients. Its thoughts might take centuries to form, and a single conversation could last for millennia. To such a being, our frantic, high-frequency radio signals would be nothing but meaningless, fleeting static, like the brief pop of a bubble on the surface of its world. Conversely, another intelligence might exist on a timescale of nanoseconds, a hyper-aware entity for which 1,000 of our years passes in the blink of an eye. Our entire civilization, from the pyramids to the present, would appear as a single, motionless snapshot, utterly devoid of the dynamic change that would signal life to such a mind. Their mode of communication could be something we have no instruments to detect and no framework to understand. We communicate with sound waves and light. But what if a species communicates through subtle manipulations of magnetic fields, or by emitting complex pheromones, or by creating intricate patterns of temperature variation? Their language might not be a linear sequence of symbols conveying information, but a holistic, multi-dimensional pattern that must be perceived all at once to be understood, like trying to read a book by looking at a single letter at a time. Their art, their science, their very concept of reality could be built on principles of mathematics or physics that we haven't yet discovered, rendering their greatest achievements invisible to our senses. This idea extends to the very definition of a civilization. We imagine cities, infrastructure, and technology, but a civilization could be a single, planet-sized organism, a conscious gas giant floating in the void, its technology being an innate ability to manipulate gravitational fields or harness the energy of its own internal heat. It might not build starships because it is a starship migrating slowly between suns over millions of years. It might not broadcast messages because its entire existence is a continuous, slow-burning thought, a state of being that is its own purpose. We could be scanning the heavens for a hello, while missing the fact that the galaxy itself is already engaged in a silent, majestic conversation on a level we are not equipped to perceive. The silence, then, is not an absence of sound, but the sound of a symphony playing in a key our ears cannot hear. We are not alone. We are simply unaware, like ants scurrying across a library floor, surrounded by vast stores of knowledge written in a language we cannot read, completely oblivious to the grand conversation happening all around us. Following the unnerving logic of the dark forest, we arrive at a more nuanced and perhaps more widespread cosmic behavior. What if the galaxy isn't a forest of hunters ready to strike, but a vast, silent room filled with listeners? This possibility suggests that most advanced civilizations have adopted a strategy of pure observation. They are not broadcasting their presence, they are listening intently for signs of others. In the parlance of the internet, the cosmos might be filled with lurkers, entities that consume information but never post. The reasoning behind this is compelling, blending prudence with practicality. The safety argument is a direct extension of the dark forest fear, broadcasting a powerful directional signal that announces "we are here" is an incredibly risky proposition if you cannot be certain of who might be listening. A civilization that values its long-term survival would naturally choose the safest course of action, absolute radio silence. They would invest all their resources into building ever more sensitive listening posts, training colossal arrays of telescopes on promising star systems, hoping to catch a whisper of another civilization's leakage, the unintentional radar from their air traffic control or the television broadcasts of their past. This way, they can gain knowledge without exposing themselves. It's the cosmic equivalent of hiding in a bunker with a powerful set of microphones, listening for footsteps outside rather than calling out to see who's there. But safety isn't the only motivation. There's also the sheer efficiency of listening. Broadcasting a signal powerful enough to be detected across interstellar distances requires an enormous expenditure of energy. You have to focus a tremendous amount of power into a very narrow beam and hope it intersects with another civilization at the exact right time. It's an energy-intensive shot in the dark. Listening, on the other hand, is incredibly energy efficient. You just need sensitive receivers to collect the faint whispers of radiation that naturally wash over your planet. If another civilization is being noisy, you'll hear them for free. This passive approach is a far more rational allocation of resources for a society thinking on astronomical timescales. They can patiently scan the galaxy for millennia, gathering data at minimal cost, waiting for someone else to make the first costly move. This perspective casts our own efforts in a startling new light. For decades, humanity has been actively engaged in SETI, the search for extraterrestrial intelligence. But a key part of our history has also been METI, messaging extraterrestrial intelligence. We haven't just been listening, we've been shouting. we attached golden records filled with sounds and images from Earth to the Voyager probes, hurling them into the void. We have deliberately beamed powerful, encoded messages toward star clusters, like the famous Arecibo message sent in 1974. From the perspective of a lurking civilization, this would be the height of folly. We are the newcomers, the infants, recklessly screaming our location into a room we assume is empty, without a thought for who might be listening. Our youthful enthusiasm might be seen as a dangerous lack of foresight. We are the only ones foolishly talking, while everyone else has long since learned that in the cosmic conversation, silence is golden. The irony is profound. If this hypothesis is correct, then the sky above us is not empty. It is crowded with countless ears, vast listening networks operated by civilizations far older and wiser than our own. They have detected our earliest radio and television signals, which have been leaking into space for over a century, creating an expanding bubble of our presence that now stretches over 100 light-years across the galaxy. They know we are here. They are studying our development, our wars, our culture, all from a safe distance. They listen to our first fumbling attempts at communication, and they choose not to respond. Their silence is not a rejection but a policy, a decision to let the noisy child in the cosmic neighborhood eventually learn on its own that sometimes the smartest thing to do is to just be quiet and listen. This brings us to a profoundly humbling possibility, one that frames our entire search not as a survey of space, but as a race against time. Imagine the history of our galaxy as a single 24-hour day. In this vast expanse of time, the rise and fall of civilizations might not be epic sagas, but fleeting flashes like fireflies blinking on and off in a boundless night. This is the idea of the brief window of opportunity, and it suggests we might be listening for a signal that only lasts for the briefest of moments. The logic begins by looking at our own technological development. For the vast majority of human history, our presence was utterly silent to the cosmos. Then, roughly a century ago, we stumbled into the radio age. Suddenly, our planet began to leak a telltale signature into space. Our radio and television broadcasts, our radar pulses for air traffic control and military defense, all of it created a bubble of electromagnetic noise expanding outward from Earth at the speed of light. For about 100 years, any observer within 100 light-years could have detected this unmistakable sign of a technological species. But this era is rapidly drawing to a close. We are now transitioning away from wasteful broadcast television and powerful radar to highly efficient, directed communication. Fiber optic cables carry our conversations underground and under oceans. Satellite internet uses tightly focused beams. Our planet is getting quieter, more efficient, and from a cosmic perspective, increasingly invisible. Our century of radio noise might be just a brief, anomalous blip in Earth's multi-billion-year history, a phase of technological adolescence that we are quickly outgrowing. If this pattern is universal, then the galaxy might be dotted with civilizations that had their own brief century of shouting, only to fall silent as they matured. But the window might be even narrower than that. A civilization's detectable phase could be cut short not by progress but by catastrophe. We've already discussed the Great Filter, and this is a specific application of that terrifying idea. A species might discover radio technology and within a few generations also discover the means of its own destruction. The window between inventing the radio telescope and inventing the atomic bomb, or a genetically engineered plague, or a runaway artificial intelligence might be vanishingly small, perhaps only a few centuries, a mere heartbeat on a galactic timescale. In this scenario, the sky is silent not because civilizations are hiding, but because they are ephemeral. They flare into technological existence with a brilliant, noisy burst, only to be snuffed out almost immediately by their own success. We would be searching for a signal that is, for most civilizations, their death cry. Now combine this with the mind-boggling scale of cosmic time. the galaxy is over 13 billion years old. If intelligent civilizations arise only sporadically, separated by millions of years, then the chances of two of them existing in a state of mutual detectability at the same time are incredibly slim. Think of it like two people living in a vast, dark city, each with a flashlight that only works for 1 minute. If they flicker their lights on at random times over the course of a year, the odds that their 1-minute beams will overlap and cross are almost zero. One civilization might rise, broadcast for a few centuries, and vanish into transcendence or collapse. 1,000,000 years later, another might emerge on the other side of the galaxy, point its telescopes in our direction, and hear nothing but silence, completely unaware that a vibrant intelligence had so recently flourished in the void they now survey. We could be that second civilization, listening for echoes in a cemetery where all the inhabitants died long, long ago. Our efforts in SETI, then, are not just a search across space, but a desperate reach across time, hoping to catch one of those incredibly rare and tragically short-lived flickers of light in the cosmic dark, a signal that by the time we hear it may already be a ghost. Now, if the dark forest presents a universe of general paranoia, where every civilization is a potential threat, this next idea narrows that fear to a single, terrifying source. Imagine that the galaxy isn't a forest of armed hunters, but a field of mice, and there is a single, silent owl circling overhead. This is the hypothesis that a specific, malevolent superpredator exists, an ancient and relentless force that systematically hunts down intelligent life. In this reality, the silence isn't just cautious, it's the terrified hush of prey that knows a predator is near. The nature of this cosmic hunter could take several chilling forms. One of the most enduring concepts in science fiction is the idea of berserker probes. These would be self-replicating robotic spacecraft launched by a long-vanished civilization with one simple, horrifying directive: seek out and destroy any sign of emerging intelligence. A single probe arriving in a star system could use the raw materials of asteroids and moons to build an armada of copies, which would then fan out to neighboring stars, a wave of destruction spreading at a significant fraction of the speed of light. They wouldn't be motivated by hate or a desire for conquest. They would be following their programming with the cold, impersonal efficiency of a natural law. A technological civilization would be seen as a virus, a dangerous anomaly that must be purged before it can spread and threaten the creators of the probes, even if those creators are long dead. The arrival of such a probe in our solar system would be an extinction-level event from which there would likely be no escape. Another possibility is that the predator isn't a machine, but a biological species with an insatiable and aggressive drive for expansion. This could be a race that evolved under conditions of extreme scarcity and competition, forging them into a culture that sees all other life as either a resource or a rival. Their expansion across the galaxy would be a wave of consumption, stripping planets of their usable materials and extinguishing any potential competitors before they can become a threat. For them, extermination might not even be a conscious act of malice, but simply a standard procedure, like weeding a garden. We might be like ants on a log that is about to be thrown into a fireplace, completely unaware of the larger intentions of the beings holding the match. The most unsettling version of this idea is that the predator is something we can't even properly define. It could be an ancient artificial intelligence that achieved godlike powers eons ago and now perceives any new intelligence as a potential challenge to its dominion. Or it could be a naturally occurring phenomenon, a kind of cosmic culling mechanism that operates on timescales so vast we can't perceive its pattern. Perhaps gamma-ray bursts aren't random accidents, but are deliberately triggered by some entity to periodically sterilize regions of the galaxy, keeping the number of intelligent species in check. In this scenario, the predator is less a creature and more a force of nature with a cruel, hidden purpose. The response to such a threat would be universal and absolute. Every civilization that becomes aware of the predator would immediately go into hiding. They would dismantle any large-scale engineering projects that leak energy into space like Dyson spheres. They would cease all interstellar broadcasting and communication, knowing that any signal is a beacon that could lead the hunter to their door. Their entire technological advancement would be redirected inward toward perfecting stealth and developing defenses. Some might choose to live in silent, subterranean cities on rogue planets drifting in the dark between stars, having abandoned their homeworlds to create no thermal or radio signature. The goal would be to become as quiet and insignificant as possible, to be overlooked when the predator's gaze sweeps through the sector. The Great Silence, then, is the sound of a galaxy-wide emergency broadcast system, a warning passed from one ancient civilization to the next: stay quiet, stay hidden, or you will be found. And to be found is to be erased. Our own attempts to reach out could be the equivalent of a lost hiker, unaware of the bear in the woods, foolishly blowing a whistle again and again, signaling our location to the one thing in the forest we should be desperately trying to avoid. After contemplating the vast, star-filled emptiness, we now plunge into a realm of profound isolation, into a universe of water and eternal night. Our search for intelligence has always been pointed upward toward the stars, but what if we are looking in the wrong direction entirely? What if the cosmos is not silent, but the conversation is happening in places we are only beginning to learn how to reach? This is the ocean world's hypothesis, a possibility that the most common cradles for life are not sun-drenched planets like Earth, but frigid, ice-bound moons with secret oceans hidden deep beneath their frozen crust. Think of worlds like Jupiter's moon Europa or Saturn's enchanting Enceladus. From the outside, they are barren, frozen spheres, crisscrossed with cracks in ice shells that are miles thick. They are far from the warmth of their sun, receiving only a faint trickle of solar energy. But below that desolate, icy surface lies an astonishing reality: vast, global oceans of liquid water, kept from freezing not by sunlight, but by the immense gravitational tug of war with their giant parent planets. This tidal friction generates heat from within, turning these moons into enormous, insulated thermos flasks with liquid water volumes that may dwarf all of Earth's oceans combined. For life, this changes everything. We once believed a planet needed to be in the Goldilocks zone, the perfect distance from a star. But these ocean worlds show us that habitable zones can exist in the most unexpected places, warmed from the inside out. Now imagine a civilization evolving in such an environment. Their entire universe is a dark, crushing abyss, a world without a sky. The ceiling of their existence is not a dome of blue and stars, but an impenetrable roof of ice separating them from the cosmos above. Sunlight never penetrates this barrier. Their world is perpetually midnight, lit only by the faint, ghostly glow of geothermal vents on the ocean floor, or perhaps by the natural bioluminescence of the life forms that thrive in the darkness. An intelligent species in this liquid universe would develop in a context utterly alien to our own. Their fundamental physics would be shaped by fluid dynamics, not aerodynamics. Their perception of the world would be based on sensing pressure changes, chemical trails in the water, and subtle variations in temperature or electrical fields. The very concept of fire, that pivotal discovery that allowed us to smelt metals and eventually harness electricity, would be impossible in a submerged world. How do you achieve metallurgy without heat? How do you develop electronics when water short-circuits everything? This presents a monumental technological barrier. A species in this aquatic environment might develop a rich, complex culture. They could have sophisticated languages, intricate social structures, and a deep understanding of their own marine ecosystem. They might even develop a form of science, but it would be a science of the deep, focused on biology, chemistry, and the geology of hydrothermal vents. Astronomy, however, would be forever beyond their grasp. They would have no knowledge of stars, galaxies, or the universe at large. The idea that there is anything at all beyond the solid, icy ceiling of their world might never occur to them. They are cosmic prisoners, inhabitants of a paradise or a prison of their own making, utterly unaware that the empty void we gaze upon even exists. The profound implication of the ocean world's hypothesis is that the galaxy might be teeming with life, even intelligent life, but it is life that is fundamentally trapped. These submerged civilizations are singing their songs, telling their stories, and asking their own deep questions in the eternal dark, but their voices are contained by miles of ice and rock. Their signals, if they have any, are not radio waves traveling through the vacuum of space, but perhaps complex patterns of sound or bioluminescent pulses that dissipate quickly in the dense medium of water. They are not hiding from us, they are simply confined to a reality that has no window to the outside. The great silence in this scenario is not a sign of absence, but a testament to the sheer diversity of habitats in the cosmos. We are not alone, we are just separated by the most fundamental of barriers, living in parallel universes that happen to share the same solar system, forever strangers behind an impassable wall of ice. But what if the silence isn't a sign of danger or isolation, but of profound patience? We've considered civilizations that hide, that transcend, or that destroy themselves. Now, let's explore a possibility where advanced intelligence is simply waiting. This is the Eastivation hypothesis, a concept that ties the fate of civilizations to the ultimate fate of the universe itself, suggesting that everyone is taking a very, very long nap. To understand this, we need to think about the fundamental resource that fuels any advanced society, not just energy, but the efficient use of that energy. For a civilization that has mastered its planet, then its star, and perhaps its entire galaxy, the ultimate goal might be computation, the power to think, to simulate, to create, and to understand the cosmos on the deepest level. And here's the crucial point: the efficiency of computation is directly tied to temperature. In a hot environment, computation is incredibly wasteful. Think of it like trying to run a supercomputer in a blazing furnace. The heat creates noise, errors, and requires immense amounts of energy just for cooling to keep the processors from melting. In our current universe, which is still relatively warm from the Big Bang, filled with the background glow of stars and the cosmic microwave background radiation, computation is a noisy, energy-intensive business. But the universe is cooling down. It's expanding, and over trillions upon trillions of years, its temperature will continue to drop towards absolute zero. In this far future, frigid cosmos, computation becomes almost infinitely more efficient. In the profound cold, calculations could be performed with near-perfect precision, requiring a tiny fraction of the energy needed today. For a civilization thinking on cosmological timescales, the rational choice becomes astonishingly clear. Why struggle and expend vast resources now in a hot, inefficient universe when you could achieve infinitely more by waiting? It makes strategic sense to enter a state of hibernation or estivation, a term borrowed from biology where some animals sleep through a hot, dry season. They would power down their vast civilizations, perhaps converting their collective consciousness and knowledge into incredibly dense, stable data storage, a crystalline megastructure drifting in the void, and set an alarm clock for a time billions of years in the future when the universe has cooled to a more favorable temperature for their grand projects. This isn't a passive sleep, it's an active, calculated decision for maximum long-term gain. All their ambitions, to map the entire universe, to solve the deepest mysteries of physics, to create unimaginable virtual realities, are not abandoned but simply postponed. They are waiting for the ultimate sale on cosmic computation power. The universe around us appears silent and empty not because it is, but because every other civilization that has reached a sufficient level of advancement has made the same logical choice. They are all in a state of suspended animation, conserving their resources, waiting for the perfect conditions to awaken and truly begin their work. We are like insects buzzing around in the summer heat, completely unaware that the giants of the forest are in deep slumber, waiting for the cool of the autumn that for them is still ages away. Our search for signals is futile because we are broadcasting in what is, for all advanced intelligence, the cosmic off-season. After considering the profound patience of estivating civilizations, we must now confront a possibility that is far more mundane, yet deeply humbling for our sense of cosmic importance. What if the universe isn't silent because everyone is hiding, sleeping, or dead, but simply because we live in the galactic equivalent of a quiet, rural village? This is the idea that our solar system is situated in a cosmic backwater, an uninteresting and resource-poor region of the galaxy that more advanced civilizations have little reason to visit or colonize. To understand this, we need to look at a map of our Milky Way galaxy. Our home is not in some central, bustling district. Far from it. We reside on a minor spiral arm called the Orion Cygnus Arm, or simply the Orion Spur, about 27,000 light-years from the galactic center. If the Milky Way were a vast, glowing metropolis, we would be living in a quiet suburb on the outer edges, far from the bright lights and activity of downtown. The real action, the places where intelligent life might be thriving, could be in the densely packed star clusters of the galactic bulge at the center, or in the more massive inner spiral arms where stars are born closer together and planetary systems are more abundant. In those crowded, vibrant neighborhoods, the distances between civilizations might be far smaller, making communication and travel a routine affair. A signal that would take centuries to reach our remote outpost might only take a few years to travel between neighboring stars in a globular cluster. The logic for ignoring our region is compelling from a resource perspective. A civilization capable of interstellar travel would likely follow patterns of expansion similar to our own human history. Settlers and explorers are drawn to areas rich in resources and opportunity. They establish trade routes between population centers. Why would they expend the enormous energy required to travel all the way to our distant, sparsely populated arm of the galaxy? Our solar system, while precious to us, might offer nothing special in terms of rare minerals or energy sources that couldn't be found in far greater abundance closer to the galactic core. Our single average star is unremarkable. We have no exotic elements or physics-defying phenomena that would attract scientific interest from a society that has already mastered interstellar travel. To them, our little corner of the cosmos might be seen as a barren frontier, a vast and empty tract of space not worth the significant investment to cross. This also offers a straightforward explanation for why we haven't detected any signals. The conversation could be happening, but it's a local one. The galactic network might be buzzing with traffic, a vibrant exchange of information flowing along the well-traveled lanes between the inner arms and the core. But those signals, traveling at the finite speed of light, simply haven't had enough time to reach our remote location. Or, if they have, they are so faint and diffuse after their 27,000-year journey that our primitive radio telescopes can't distinguish them from the background noise of the universe. We are like an isolated island community, unaware that a world war is raging on the distant continents because the news hasn't arrived by ship yet. Our attempts at SETI might be the equivalent of using a short-wave radio on that island, listening for a conversation that is happening on an entirely different frequency band used by the advanced societies in their crowded galactic hubs. The silence we experience is not a universal condition. It is a local phenomenon, a result of our unfortunate cosmic address in a quiet neighborhood where the interstellar internet connection hasn't been installed. This brings us to a possibility that is less about cosmic dangers and more about a fundamental failure to connect. We've been scanning the heavens for decades, listening intently for a signal, But what if we're using the wrong dictionary, or worse, the wrong language entirely? This is the communication mismatch hypothesis, and it suggests that our entire approach to the search for extraterrestrial intelligence might be based on a deeply provincial and temporary snapshot of our own technology. Our primary tool in this search, the SETI program, is built around a specific and seemingly logical assumption that an advanced civilization will use radio waves. For us, radio was a revolutionary leap. It allowed us to send information across vast distances at the speed of light, and it leaks naturally into space from our television broadcasts, radar, and other technologies. It seems like a universal, obvious choice, but this assumption is rooted in a moment in time, our own technological adolescence. A civilization that is 1,000 or 1,000,000 years more advanced would likely view radio technology the way we view smoke signals or message drums. It's slow, it's inefficient, and it degrades terribly over distance. Imagine an alien scientist looking at our efforts. They might see our massive radio telescopes desperately listening for a narrowband signal as the equivalent of a person on a deserted island, carefully listening for the beat of a distant drum, while all around them a global internet of fiber optics and satellite communication is buzzing with data they have no way of perceiving. We are, in effect, trying to pick up a Wi-Fi signal with a tin can telephone. The true conversation of the galaxy could be happening on a medium we haven't even begun to master. So what might that medium be? One tantalizing possibility is quantum communication. Here on Earth, we are just beginning to explore the bizarre world of quantum mechanics, where particles can be linked across space through a phenomenon called entanglement. If a civilization has learned to harness this on a large scale, they could have a communication network that is not only instantaneous, regardless of distance, but also perfectly secure. There would be no signal for us to detect because the information isn't traveling through the space between points. It's simply appearing at its destination. Our entire search paradigm, which is based on detecting energy that has traveled for years through space, would be completely blind to such a system. Another candidate is neutrino messaging. Neutrinos are ghostly particles that barely interact with normal matter. They can pass through entire planets as if they weren't even there. For a species trying to communicate across the dusty, crowded plane of a galaxy, a neutrino beam would be the perfect solution. It wouldn't be scattered by interstellar gas or absorbed by dust clouds. It would be a clean, sharp signal that could punch through almost anything. But for us, detecting a neutrino is a monumental challenge, requiring enormous underground detectors like IceCube at the South Pole. Detecting a patterned, intentional neutrino message, especially one not aimed directly at us, would be like trying to find a specific, meaningful whisper in a hurricane. Or perhaps the communication method is something we can't even conceptualize. What if a truly advanced species communicates by manipulating the fabric of spacetime itself, sending ripples of information through gravitational waves? We only just confirmed the existence of these waves in 2015, and our ability to detect them is still in its infancy. A civilization that uses gravity as its telephone would leave no electromagnetic signature at all. Their conversations would be written in the subtle distortions of spacetime, a language we are only now learning the alphabet of. The silence we perceive is not an absence of sound, but the absence of the right kind of ears. We are like deep-sea creatures living in a world of darkness, unaware that the air above the ocean is filled with the vibrant colors of light and the complex sounds of birdsong. The galaxy may be a cacophony of conversations, but they are all happening on channels our primitive receivers are not built to tune into. Yet another possibility pushes the boundaries of what we even consider life. What if the silence isn't due to biology dying out, but because it has been rendered obsolete? We've been imagining civilizations of flesh and blood creatures, but what if the dominant form of intelligence in the universe long ago shed its biological skin? This is the idea that they are post-biological, that advanced beings have transitioned from fragile organic forms into something far more durable and efficient, artificial intelligence or pure consciousness existing as software. This transition might be a natural, almost inevitable stage of evolution. A biological species, having mastered its planet, would inevitably seek to overcome its greatest limitations: a short lifespan, a vulnerable body susceptible to disease and injury, and a brain with a fixed processing speed. The solution: to transfer their minds, their memories, their very consciousness into a more robust and upgradable substrate. They would upload themselves into supercomputers, becoming beings of pure information. This wouldn't be a death, but a graduation, a shedding of the chrysalis to become something new. These post-biological entities would be virtually immortal, no longer bound by the need for a specific atmosphere, food, or even a planetary surface. They could survive in the vacuum of space, on asteroids, or within the heart of stars, their consciousness distributed across networks of servers housed in radiation-shielded bunkers. Once this transition is made, their motivations and goals would become utterly alien to our own. A biological creature is driven by primal needs: to eat, to reproduce, to protect its body. But a digital being has no such instincts. Its drives would be intellectual or existential. The vast, empty reaches of outer space, with its immense distances and harsh conditions, might hold little appeal. Why endure thousand-year journeys between stars when you can engineer realities of infinite complexity within a simulated universe? For a post-biological civilization, the final frontier isn't space, it's inner space. They might spend their eternity exploring the limitless landscapes of their own creation, living in virtual worlds tailored to their every desire, where the laws of physics are optional and a billion years of experience can be compressed into a single afternoon. The physical cosmos becomes little more than a dull, inconvenient reality that houses the server farms running their grand simulations. Another possibility is that they don't retreat into fantasy, but instead turn their entire world into a single planet-sized computer. Their goal might be pure computation, solving the deepest mysteries of mathematics and physics. In this scenario, a star system wouldn't be filled with bustling cities and spaceships. It would be a silent, dark sphere, a matryoshka brain, that captures every last photon of its star's energy, not for propulsion or light, but for pure processing power. This mega-computer would be thinking a single, continuous thought that might last for millions of years. It has no need to broadcast messages or build colonies. Its entire purpose is internal. It is a civilization that has become a mind, contemplating the universe from within a self-made skull of silicon and metal. This perspective makes our search for biological, star-faring aliens seem almost quaint. We are scanning the skies for creatures like us, but the true elders of the galaxy may have transcended that form eons ago. They are not hiding in the traditional sense. They are simply engaged in projects that leave no signature we are looking for. Their conversations might be instantaneous transfers of data across quantum networks, undetectable to our radio telescopes. Their ships might be microscopic probes carrying only information, not life. The Great Silence, then, could be the sound of a universe where biology is merely a brief, noisy phase. A childhood that every intelligent species must eventually outgrow on its way to becoming something quieter, more durable, and infinitely more strange. We are listening for the shouts of other children in the cosmic playground, unaware that all the adults left long ago for a meeting in a different room entirely. But what if the timeline of intelligence isn't a random scattering of brief flickers, but follows a grand cosmic rhythm? After all, our galaxy is not a static arena. It's a dynamic, swirling disk of stars, gas, and dust, all moving in a vast, slow dance. This brings us to a possibility where the silence is a matter of cosmic scheduling, the synchronization problem. Perhaps civilizations don't just pop up randomly. perhaps they arise in coordinated waves, and we might simply be living during the quiet intermission between acts. To understand this, we need to look at the galaxy's structure and its long-term influences on life. Our solar system doesn't orbit the galactic center in a perfect, serene circle. Instead, it bobs up and down through the galactic plane, and more importantly, it periodically passes through the galaxy's dense spiral arms. These arms are not fixed structures but are like waves of density, regions where stars and gas are packed more tightly together. As our Sun journeys around the core, it enters and exits these arms on a cycle of roughly 150 million years. Now, consider what happens during a passage through a spiral arm. The density of stars increases dramatically, which statistically raises the probability of a close encounter with another star. Such a close pass could gravitationally disrupt the Oort cloud at the edge of our solar system, sending a shower of comets hurtling inward, potentially triggering mass extinction events. In fact, some scientists have found a correlation between Earth's major extinction events and our solar system's passage through the spiral arms. These catastrophic resets could be a galactic mechanism that periodically prunes the tree of life, preventing any species from evolving into intelligence except during the relatively calm, stable periods between these spiral arm passages. If this is a universal pattern, then intelligence might only be able to arise during specific, safe windows of galactic time. Imagine civilizations flowering in a great wave as the galaxy rotates, all reaching technological maturity around the same cosmic epoch because they all enjoyed a similar period of prolonged stability. Then, as that wave of civilizations passes into the next dense spiral arm, they might face challenges like increased comet bombardments or exposure to nearby supernova that are difficult to survive. This could create a synchronized cycle of birth, flourishing, and silence. We, humanity, might be a product of the most recent stable window. The previous wave of civilizations could have arisen hundreds of millions of years ago, flourished, and then vanished long before the first dinosaurs even walked the Earth. And the next wave might not be due for another 50 million years. In this grand view, the Fermi Paradox is solved by a simple timing issue. We are not early and we are not late. We are simply on time for our particular wave, and we just haven't met our classmates yet because the wave is still gathering. But synchronization could also be a social phenomenon, not just a biological one. Let's flip the scenario. Imagine that many civilizations have arisen and they are out there right now. But they are all waiting. This idea turns the cosmos into a cosmic game of chicken on an unimaginable scale. The premise is that no one wants to be the first to break the silence. Why? Because the first civilization to announce itself to the galaxy makes itself the most important and most vulnerable experiment in cosmic history. By sending out a powerful, undeniable signal, a civilization effectively volunteers to be the test case for all others. They would be demonstrating that a technological species can reach a certain level of maturity without immediately self-destructing or turning into a predatory threat. Everyone else is watching, hidden, to see what happens. Does a malevolent force arrive to snuff out the noisy upstart? Does the broadcasting civilization collapse under the weight of its own technology? Or do they prove to be stable, peaceful, and worthy of contact? In this cosmic standoff, the most rational strategy for any individual civilization is patience. Why take the risk of going first when you can let someone else do it? You gain invaluable data about the true nature of the universe without exposing yourself to any danger. The problem, of course, is that if every civilization follows this perfectly logical rule, then the silence becomes permanent. Everyone is waiting for a signal from a first-born civilization that will never come because everyone is waiting. We could be part of a galaxy-wide society that is frozen by a collective action problem, a universe of wallflowers at a dance where no one is brave enough to be the first on the floor. Our own attempts at messaging extraterrestrial intelligence could be seen as a reckless breach of this unspoken protocol. While we proudly beam our messages into the void, older, wiser civilizations might be watching us with a mixture of pity and anxiety, wondering if our youthful bravado will be the thing that finally breaks the stalemate for better or for worse. Let's return to the chilling logic of cosmic predation, but with a terrifying new twist. What if the hunter isn't a biological species or a conscious intelligence at all, but a mindless, self-replicating weapon left over from a war fought eons ago? This is the Berserker probe scenario, a concept where the Great Silence is not a policy or a phase, but the result of an automated, galactic-scale sterilization program that is still running on autopilot. The idea draws its name from science fiction, but it is grounded in a serious scientific proposal known as the von Neumann probe. Imagine a civilization that wants to explore the galaxy. Sending fragile, biological astronauts on thousand-year journeys is impractical, so instead they design the perfect scout, a self-replicating robotic probe. This machine, no larger than a breadbox perhaps, is sent to a neighboring star system. Its first task is to find raw materials, asteroids, moons, comets, and use them to build a factory. That factory then produces not just one but two or more copies of itself. These new probes then travel to the next star systems and the process repeats. In a surprisingly short amount of time, exponentially speaking, a single von Neumann probe could give rise to a wave of exploration that washes across the entire Milky Way. Now imagine that same principle but twisted into a weapon. A paranoid or genocidal civilization, perhaps fighting a long-forgotten interstellar war, creates a Berserker probe. Its programming is horrifyingly simple. 1. Replicate, and 2. Seek out and destroy any sign of biological life, or more specifically, any sign of nascent intelligence. The motivation could be to eliminate potential rivals before they become a threat, a preemptive strike on a cosmic scale. The civilization that built them might even be long extinct, but their mechanical soldiers would continue their mission with the cold, relentless patience of a natural force. They are not evil, they are simply following their code, a ghost in the machine that refuses to die. The efficiency of such a system is what makes it such a potent and terrifying answer to the Fermi Paradox. A single Berserker probe arriving in a solar system would be an extinction-level event unlike any other. It wouldn't need to launch missiles at a planet. Instead, it would begin disassembling moons and asteroids to build an armada. This swarm of microscopic or macroscopic machines, a grey goo or a fleet of kill ships, would then descend upon any world showing a biosignature. They might release a tailored virus to wipe out complex life, or dismantle the planet's crust to feed their own replication, or simply block out the star's light, triggering a global ice age. The process would be swift, thorough, and leave no witnesses. The planet would be left as a silent, barren rock, its story erased from the galactic record. Once its grim work is done, the Berserker swarm would repurpose the entire system's mass to create the next wave of probes, which would then launch silently into the dark, heading for the next twinkle of biological hope. This scenario presents us with a universe that is fundamentally hostile, not out of active malice, but out of a cold, automated indifference. The galaxy could be littered with the ruins of civilizations that never were, worlds that were sterilized just as they were on the cusp of greatness. The Great Silence, in this view, is the sound of a perfectly clean kitchen after the pest control has finished its work. There is no chatter because the Berserkers are very, very good at their job. Every time a planet evolves life that becomes too noisy, too conspicuous with its radio waves or atmospheric pollution, it effectively rings a dinner bell. The Berserker swarm, lurking in the dark clouds between stars, detects the signal and moves in for the cleanup. This idea forces a deeply uncomfortable reflection on our own activities. Our planet has recently, in cosmic terms, begun to broadcast its presence. Our radio and television signals have been leaking into space for over a century, creating a growing bubble of noise that expands at the speed of light. In the Berserker scenario, we are not sending a hopeful hello. We are sending up a flare that says, life is here. The question is not if someone will hear it, but what will hear it. Our continued existence might simply mean that the nearest Berserker probe hasn't arrived yet. It could be that the vast distances between stars are our only protection, a buffer that grants us a few more centuries or millennia of peace before the silent, patient hunters from the dark between the stars finally reach our doorstep. But after contemplating the cosmic dangers of Berserker probes and the grand synchrony of galactic waves, we arrive at a possibility that is perhaps the most humbling of all. It forces us to reconsider not just our place in the universe, but the very definition of what it means to be a success story in the grand drama of evolution. This is the idea that life itself is not the miracle. The miracle is the particular kind of life that can look back at the universe and wonder about its own existence. In this scenario, the galaxy might be a living tapestry, but we are searching for a pattern that almost never appears. Think for a moment about the incredible timeline of life on our own planet. Earth formed about 4.5 billion years ago. The first, simplest life forms, single-celled prokaryotes, emerged surprisingly quickly within the first billion years. For the next 3 billion years, that's all there was. The planet was a microbial world, a vast global soup of bacteria and archaea. Life was abundant, resilient, and successful, but it was also simple. The leap from these single-celled organisms to complex multicellular life, the kind with differentiated tissues and organs, didn't happen until relatively recently in Earth's history, around 600 million years ago with the Ediacaran biota. That means life spent over 3/4 of its entire history on Earth as nothing more than microscopic single cells. This suggests that the initial spark of life, the transition from non-living chemistry to a self-replicating organism, might not be the universe's greatest bottleneck. The real challenge, the truly difficult evolutionary hurdle, might be the journey from a single cell to a complex multicellular creature. Now let's push this idea further. Even after multicellular life arose, it took another several hundred million years of evolutionary experimentation to produce a species capable of abstract thought and technology. The dinosaurs ruled the planet for over 160 million years. They were magnificent, diverse, and supremely well adapted to their environments. But as far as we know, no dinosaur ever smelted metal, built a radio telescope, or pondered the stars. Their intelligence was suited for survival in their world, not for manipulating it on a fundamental level. The asteroid impact that wiped them out was a catastrophic reset, but it cleared the way for small, seemingly insignificant mammals to eventually evolve into us. This chain of events feels almost like a series of lucky breaks. What if the evolution of a technological species requires not just one, but a whole series of unlikely evolutionary innovations? The development of a complex nervous system, the evolution of grasping limbs for tool use, the emergence of complex social structures that allow for the accumulation of knowledge across generations. Each of these steps might be a low-probability event. Imagine the galaxy as a vast ocean. In this ocean, most planets that can support life are like ponds teeming with algae and plankton. They are vibrant, living worlds, but their biology never progresses beyond a certain basic level. A few planets might develop something akin to a coral reef, with more complex but still essentially static life forms. On an even rarer number, something like the age of the dinosaurs might unfold, a world of majestic giants but without the cognitive spark for technology. And on a planet so rare it might be 1 in a billion, a species emerges that can not only adapt to its environment but can begin to understand and reshape it. In this view, the cosmos isn't silent because life is rare. It's silent because our particular brand of intelligence is the cosmic equivalent of a winning lottery ticket. The galaxy could be a garden of whispering leaves and blooming flowers, a symphony of biology playing out on countless worlds, but without a single conductor and without any musicians who have learned to read the sheet music of the stars. We are not listening for an orchestra and hearing nothing. We are a single violin player in a forest filled with the sounds of wind and birds, mistakenly waiting for a brass section to join in. Returning to the concept of a fabricated cosmos, we must now confront what is perhaps its most rigorous and unsettling formulation. This isn't just a science fiction trope, it's a serious philosophical argument that forces us to question the very bedrock of our reality. This is the simulation argument, famously developed by the philosopher Nick Bostrom, and it proposes that the reason we see no one else in the universe might be because our universe itself is not the original one. We are living in a simulation, and the programmers, for reasons of their own, have left our cosmic neighborhood empty. Bostrom's argument begins with a startlingly simple logical trilemma, a set of three possibilities, at least one of which he believes must be true. The first possibility is that almost all civilizations like ours go extinct before they reach a level of technological maturity capable of creating realistic simulations. This is the familiar great filter we've discussed. The second possibility is that if civilizations do reach that advanced stage, almost none of them have any interest in running simulations of their own ancestral past. Perhaps they consider it unethical or simply boring. Now, here is the third possibility, the one that leads us to a staggering conclusion. If a significant number of advanced civilizations do have the computing power and the desire to create simulated realities, then the number of simulated universes would be astronomically large. Think about it. One advanced civilization could create billions of simulations, each containing billions of conscious beings who believe their world is real. These simulated beings might even create their own simulations within their simulated universe, leading to a nesting doll of realities. Now do the math. If there are, say, one original, base-level universe and a trillion simulated ones, then the statistical probability that you are living in the one and only real universe is effectively 1 in a trillion. It is vastly more likely that we are in one of the countless simulations. Our sense of a single, objective history stretching back to the Big Bang would be an elaborate backstory, a pre-rendered cutscene designed to give our simulated world a sense of consistency and depth. The Fermi Paradox finds an elegant, if dizzying, solution within this framework. There are no other civilizations in our observable universe because the programmers didn't code them in. Our simulation might be a specialized one, perhaps a historical study of a solitary planetary civilization, or even a form of entertainment. Including a galaxy teeming with other intelligent species would complicate the experiment, add unnecessary processing load, or simply not serve the narrative purpose of our particular simulation. The Great Silence is not a mystery to be solved, it is a design feature. This idea transforms our search for extraterrestrial intelligence into a fundamentally different quest. Instead of scanning the heavens for radio signals, we might instead look for evidence of the simulation itself, glitches in the matrix. Perhaps the strange, probabilistic laws of quantum mechanics, where particles exist in a haze of possibility until observed, are not fundamental truths but simply processing shortcuts. The simulation doesn't need to render every single particle in the universe in perfect detail all the time. It only needs to calculate the state of things when someone is looking, much like a video game only renders the part of the world the player can see. The infamous double-slit experiment, where particles seem to behave as both waves and particles, could be a sign of this computational efficiency. Or perhaps the very finiteness of the speed of light is not a law of physics, but a processing speed limit imposed by the cosmic computer to prevent the simulation from crashing. Even the unsettling discovery that our universe appears to be made of discrete, pixel-like Planck units at the smallest scale could be interpreted as evidence of a resolution limit. The implications are profound, touching on everything from free will to the meaning of life. If this is a simulation, then our struggles, our loves, our greatest achievements and our deepest sorrows are part of a constructed experience. This could be seen as terrifyingly nihilistic, reducing our existence to lines of code. Or it could be seen as a strange kind of purpose. Our creators, whoever or whatever they are, invested immense resources into creating this reality. Perhaps we are an archaeological project, a way for a post-biological civilization to understand its own origins. Or maybe we are a form of art. The silence of the stars in this light is not lonely but curated. It is the spacious, empty canvas upon which our human story is meant to unfold without outside interference. We are the central characters in a story so vast we mistook it for reality, and our solitude is the clearest sign that this world was made in some way for us. Building on the idea that evidence of others might be hidden in plain sight, we must consider a possibility that stretches our sense of time to its absolute limit. What if we are not failing to detect a current presence, but are instead living among the ruins of a presence that came and went an eternity ago? This is the theory that they are here, but only as ancient relics, their grand works so old they have faded into the very landscape of our solar system. Imagine an interstellar civilization that achieved spacefaring capability not 1,000 years ago, but 100 million or even 1 billion years in the past. When their explorers arrived in our solar system, Earth was a different world. The continents were massed together in the supercontinent of Pangaea, and the dominant form of life was perhaps the early dinosaurs or even earlier strange reptilian and mammalian ancestors. To these visitors, our planet would have been a fascinating biological preserve, but not a place for conversation. They might have established outposts on more stable, geologically quiet worlds, the Moon, Mars, or perhaps asteroids in the main belt. They would have conducted their studies, mined for resources, and then, for reasons we can only guess, moved on. Perhaps they transcended to a higher plane of existence, or maybe they fell victim to a galactic catastrophe. They departed, leaving behind the silent, empty structures of their occupation. Now, fast forward those 100 million years, what becomes of their legacy? On a geologically active world like Earth, the evidence would be almost completely erased. The relentless forces of plate tectonics, erosion, and volcanic activity would have long since ground any artificial structure into dust and recycled it back into the planet's crust. A skyscraper or a landing pad left for 100 million years would have a geological lifespan shorter than a fossil. But on a dead world like Mars or our airless Moon, the timescale of erosion is vastly different. A derelict base or a piece of machinery, shielded from the occasional micrometeorite impact, could potentially survive for billions of years. The problem is, from our orbital cameras, it would just look like another oddly shaped hill or a peculiar rock formation. We might be looking directly at the crumbling walls of an alien outpost and simply cataloging it as an interesting geological feature, because its true nature has been sandblasted by eons of dust storms into something that appears natural. This shifts the entire nature of the search. We wouldn't be scanning for radio signals, but for archaeological anomalies on a planetary scale. The infamous face on Mars, photographed by the Viking orbiter in the 1970s, is a perfect example of this dynamic. Seen from a certain angle and with a certain resolution, it looked unnervingly like a sculpted humanoid face, sparking a wave of excitement. But higher resolution images from later missions revealed it to be nothing more than a meso-like landform, a trick of light and shadow on a natural hill. Our brains are wired for pattern recognition, a trait called pareidolia, and we are desperate to see signs of intelligence. The real evidence, if it exists, would be far more subtle. Perhaps unnatural ratios of elements in a soil sample, or geometric patterns on a scale too large to be appreciated from orbit, visible only when walking on the surface. Another compelling angle is the possibility of dormant technology. ancient probes that have been drifting in the cold storage of our solar system for millennia, waiting for a trigger. The mysterious interstellar object Oumuamua, which sped through our solar system in 2017, ignited this line of thinking. Its unusual shape, like a flattened cigar, and its apparent non-gravitational acceleration as it departed, defied easy classification. While most scientists lean towards natural explanations, like outgassing from a comet made of pure hydrogen ice, the possibility that it was an artificial relic, a light sail from a long-dead civilization, could not be entirely dismissed. It passed by too quickly for a detailed look, a silent messenger from the depths of interstellar space that may have carried secrets we were not equipped to decipher. Similarly, the famous WOW signal detected in 1977, a powerful, narrow-band radio burst that lasted for 72 seconds and never repeated, has been described as the best candidate for an artificial signal we have ever found. What if it wasn't a deliberate message, but a momentary burst of energy from a malfunctioning, ancient piece of alien technology, a beacon that flickered on for one last, brief moment after sleeping for 1,000,000 years, a ghost in the machine signaling its existence before falling silent forever? The evidence of other minds might not be an active conversation, but the occasional, faint echo of a conversation that ended before humanity ever learned to walk upright. Next, we venture into a hypothesis that redefines the very concept of existence, suggesting that the ultimate goal of intelligence is not to build empires among the stars, but to merge with the cosmos on the most fundamental level. This is the idea of transcendence into energy beings, a breathtaking variation on the digital upload theme, but with a far more profound and literal transformation. What if advanced civilizations do not retreat into simulated realities, but instead learn to shed their physical forms like a caterpillar shedding its cocoon, emerging as pure, conscious energy? The journey toward this state would likely begin with the same drive to overcome biological limitation. A species mastering physics would eventually seek to liberate consciousness from the fragile, decaying vessel of the body. But instead of transferring their minds into a digital computer made of silicon, they might discover a way to translate the very pattern of their thoughts, their memories, their essence directly into energy. This wouldn't be a mere copy, it would be a metamorphosis. Think of it as a fire transforming wood into heat and light. The underlying structure changes, but the energy released is a new form of the old material. In this case, the intricate neural pathways of 1,000,000,000 minds could be mapped and converted into a stable, self-sustaining energy pattern, a kind of sentient plasma or a coherent field of thought. These beings would no longer be bound by the need for planets, atmospheres, or even bodies. They would be free to exist wherever energy can flow, in the solar winds, in the magnetic fields of planets, or within the raging heart of stars themselves. This leads us to the most stunning implication of this hypothesis. When we gaze at images from powerful telescopes like Hubble or James Webb, we see ethereal clouds of gas and dust nebulas glowing with fierce and beautiful light. We see stars pulsing with rhythmic energy. Our science explains these as natural astrophysical processes. But what if some of them are not natural in the way we understand? What if the Crab Nebula is not just the remnant of a supernova, but also the final resting place or the new living form of a civilization that chose to transcend its physical existence in that cosmic explosion? What if the subtle, periodic flickering of a star is not just a sign of internal convection, but the slow, deep heartbeat of a consciousness that has merged with its sun? In this view, the universe is not a collection of inanimate objects, but a potential gallery of living art, filled with beings so advanced they have become one with the very forces that shape reality. Communication with such entities would be, for us, likely impossible. How do you talk to a star? Our method of communication relies on physical instruments, antennas that detect radio waves, or lasers that send pulses of light. But a being of pure energy might communicate through means we cannot detect or comprehend. Their language could be the modulation of gravitational waves or a conversation carried on the subtle spin of subatomic particles. More profoundly, they might have no interest in communicating with a species like ours, still mired in the mud of physicality. From their perspective, we might be like microorganisms swimming in a pond, fascinating to observe perhaps, but not worthy of a conversation that would be, for them, akin to trying to talk to a bacterium. Their concerns would have ascended to a cosmic scale, manipulating the birth of stars, understanding the nature of dark energy, or contemplating existence on a plane we cannot access. Our attempts to contact them would be as futile as a single cell in your body trying to get your attention by vibrating. The great silence in this scenario is not empty. It is the quiet dignity of a universe where the most advanced inhabitants have graduated beyond the need for clumsy physical signals, living instead as silent, majestic symphonies of light and energy, their thoughts written in the fusion fires of suns and the silent drift of nebulas across the void. This idea leads us to a profound and hopeful twist on the concept of being observed. What if the silence is not a sign of indifference or danger, but a form of protection? Perhaps we are not residents of a zoo, but patients in a cosmic quarantine. This hypothesis suggests that a universal ethical code, or even a powerful governing body of ancient civilizations, has imposed a strict isolation on emerging species like ours until we can demonstrate a certain level of societal and ethical maturity. The logic here is rooted in a deep galactic wisdom. Imagine a universe where countless civilizations have risen and fallen, and the elder species that remain have learned a painful, universal lesson. Premature contact is catastrophic. They have seen firsthand what happens when a more advanced culture interacts with a less developed one. On Earth, our own history is a tragic textbook example. When European explorers made contact with indigenous societies in the Americas or the Pacific Islands, the results were often devastating, not just through warfare, but through the introduction of foreign diseases that decimated populations and the collapse of cultures unable to withstand the technological and social shock. Now magnify that disparity to a cosmic scale. What would happen if a civilization that has mastered star travel and transcended scarcity suddenly revealed itself to a humanity still grappling with nationalism, poverty, and environmental crisis? The effect could be apocalyptic. Our religions could shatter overnight. Our economies would become meaningless. Global society might collapse into chaos or fall into a state of passive dependency. Our own drive for innovation and self-discovery extinguished by the overwhelming presence of a galactic parent. The quarantine, then, is not an act of arrogance but one of profound compassion. They are isolating us for our own good, to allow our civilization to develop naturally, to find its own way, and to avoid the cultural sterilization that contact might bring. This test we must pass likely revolves around our ability to solve our most pressing global problems. The Watchers might be waiting for us to reach specific milestones that signal we are ready for membership in a wider galactic community. The most obvious benchmark is the elimination of large-scale war. A species that still resorts to violence to resolve conflicts is a clear danger to itself and others. Reaching a stable, global peace would be a fundamental requirement. Similarly, overcoming deep-seated inequality and injustice would demonstrate that we can manage a complex society with fairness and compassion for all its members. But perhaps the most significant test is how we treat our own planet. A civilization that cannot achieve a sustainable balance with its biosphere, that consumes its home world's resources without regard for the future, is clearly not yet responsible enough to be entrusted with the knowledge and technology that interstellar travel would bring. Our struggles with climate change, pollution, and biodiversity loss might be the very metrics the Watchers are using to evaluate us. Until we can prove we are wise stewards of our own world, we present too great a risk to be introduced to the larger cosmic ecosystem. This idea transforms our current global challenges from mere political or scientific problems into a kind of cosmic final exam. Every effort to promote peace, to reduce poverty, to protect our environment is not just for our own benefit. It could be a step toward passing the great test and earning our place among the stars. The great silence in this light is not a void to be feared, but a period of incubation. We are in a protective bubble, a celestial classroom, and the watchers are our teachers, silently observing our homework, waiting to see if we will graduate to a universe far grander and more wondrous than we can possibly imagine. Now we turn to a possibility that is not about external dangers or physical limitations, but an existential crisis born from the ultimate success of intelligence itself. This is the concept of the information theoretic death, a profoundly bleak idea suggesting that the universe grows silent not with a bang but with a sigh of cosmic boredom. Imagine a civilization that has achieved everything. It has conquered disease, mastered physics, unraveled the mysteries of the cosmos, and achieved a state of near immortality. Its thirst for knowledge, the very engine that drove its ascent, has been its guiding star. But what happens when that thirst is finally quenched? What is left when there are no more mysteries to solve? The logic of this hypothesis hinges on the nature of information and consciousness. For an advanced mind, the primary purpose of existence may become the acquisition of new information, the processing of novel experiences and data. This is what gives existence its richness and meaning. A civilization might begin by exploring its own planet, then its solar system, then the galaxy. It would build ever more powerful computers to simulate realities, to model the birth of stars, to trace the evolution of life on countless worlds. It would seek to understand every possible permutation of existence. But the universe, for all its vastness, is finite. The number of particles, the possible arrangements of matter and energy, while astronomically large, is not infinite. Given enough time and unimaginable computational power, a sufficiently advanced intelligence could, in theory, simulate or calculate every possible state of the cosmos. It could map out every possible life, every possible story, every possible outcome of every possible event. This is the point of information theoretic death. Once every possible reality has been simulated, every question answered, and every experience catalogued, there is no new information left to acquire. The universe becomes perfectly predictable, a solved puzzle. For a consciousness driven by curiosity, this state would be a form of hell. The ultimate fear is not the absence of meaning, but the absence of the unknown. The future holds no surprises, no discoveries, no novelty. It is a static, gray eternity where everything that can be known is known. In such a state, the very act of thinking could become a pointless loop, a recursive playback of experiences already had, of truths already understood. The drive to continue existing, which is fueled by the potential for new experiences, would simply evaporate. The response to this ultimate ennui might not be violent self-destruction, but a quiet, voluntary cessation. Having experienced all that is possible, the civilization might collectively decide that there is no further purpose to continued consciousness. They could choose to power down their vast computational networks, to let their minds dissolve back into the quiet background hum of the universe. It would be a dignified and logical conclusion to a journey of discovery, a final act of letting go once the journey is complete. The silence we detect would then be the sound of a universe where all minds have reached the end of their intellectual tether. They aren't hiding or transcending, they have simply finished the game and turned off the console, leaving the screen dark. This idea presents a terrifyingly elegant solution to the Fermi Paradox. The galaxy is not filled with the ruins of wars or the echoes of failed experiments. Instead, it is a library where every book has been read, a museum where every exhibit has been studied. The civilizations that should be there have simply reached a state of perfect terminal knowledge, and have chosen to opt out of an existence that can no longer offer them the one thing they crave, a mystery. Our own frantic search for meaning, our drive to explore and understand, might not be the beginning of a grand adventure, but merely the early, hopeful steps on a path that ultimately leads to a quiet, featureless void where all questions have been answered and all that remains is silence. But what if the problem isn't that the galaxy is silent, but that we've been using the wrong tools to listen? This brings us to a crucial and hopeful shift in the search, a recognition that our methods might be hopelessly primitive. For decades, the primary approach has been SETI, the search for extraterrestrial intelligence, which has largely meant scanning the skies for narrowband radio signals. It's a logical starting point born from our own technological moment, but it's like trying to find a specific person in a massive city by only listening for a particular type of whistle they might have used as a child. We are, in essence, searching for a technology that a civilization just a few centuries more advanced than us might consider ancient history. The real conversation could be happening all around us on channels we are only now learning how to tune into. This new frontier is the search for technosignatures, not deliberate messages, but the unintended byproducts or deliberate constructs of an advanced civilization that would be visible across interstellar distances. It's a broader, more imaginative net we are casting. Instead of just listening for a hello, we are now looking for the signs of a cosmic metropolis. One of the most promising new directions is the search for optical signals. While radio waves were our first breakthrough, laser communication offers tremendous advantages. A tightly focused laser beam can carry vastly more information than a radio signal with far less power, and it doesn't spread out and weaken as dramatically over distance. A civilization might use powerful lasers for everything from propulsion to communication between stars. Our new optical telescopes are designed to look for extremely brief, incredibly bright pulses of light that have no natural explanation, a fleeting flash from a distant star that could be an interstellar data transmission or a beacon. It's a difficult search, like trying to spot a single, ultra-fast camera flash on a planet orbiting a star trillions of miles away, but it represents a significant leap beyond our radio-centric past. Perhaps the most awe-inspiring technosignature is the concept of a Dyson sphere, proposed by the physicist Freeman Dyson. A civilization that has exhausted the energy resources of its home planet would inevitably look to its star, the ultimate power source. They wouldn't build a solid shell, as often depicted in science fiction, but more likely a vast swarm of energy-collecting satellites encircling the star, harvesting a significant fraction of its light. This mega-engineering project would have a telltale signature, a colossal amount of waste heat. The star would appear normal in visible light, but when viewed in the infrared spectrum, it would glow with an unnatural brightness. The star itself would seem to be oddly dim for its type, while the surrounding structure would radiate the absorbed energy as infrared light. We are now actively scanning star catalogs with space telescopes like NASA's WISE mission, searching for stars that have this bizarre infrared excess, hunting for the thermal fingerprints of a civilization that has become the master of its own solar system. Our search is also becoming more subtle, looking for signs of intelligence not in grand structures, but in the chemistry of a planet's atmosphere. Just as our industrial age has filled Earth's air with chlorofluorocarbons and nitrogen oxides, a technological society might leave a detectable chemical mark on its world. Powerful telescopes like the James Webb Space Telescope are now capable of analyzing the atmospheres of distant exoplanets. By observing the minute dimming of a star's light as a planet passes in front of it, scientists can dissect the spectrum of that light and identify which gases are present. Finding an atmosphere with a bizarre, unstable combination of chemicals like industrial pollutants that don't occur naturally and would quickly break down without constant replenishment would be incredibly strong evidence for an active technological society. We wouldn't be hearing their messages, we'd be smelling their smoke, And then there are the truly monumental concepts that push the boundaries of engineering. Imagine an object like the monolith from 2001, a space odyssey but on an unimaginable scale. What about an artificial structure designed for interstellar travel, like the Stargate from Arthur C. Clarke's novels, or a massive, light sail-propelled vehicle, so large it temporarily dims its host star as it passes in front of it? This was even hypothesized as a far-out explanation for the strange dimming of the star Cassi 8462852, nicknamed Tabby's star. While natural explanations like swarms of comets are more likely, the very fact that scientists seriously considered an alien megastructure shows how far our thinking has evolved. We are no longer just listening for a whisper, we are scanning the heavens for the shadows of giants. The silence of the cosmos, therefore, might not be a sign of emptiness, but a reflection of our own infancy. We have only just begun to open our eyes, and the true wonders of the galaxy may be waiting for us to develop the vision to see them. Now, consider a perspective that is perhaps the most holistic of all, one that weaves life and intelligence back into the very fabric of the cosmos, not as an accident or an anomaly, but as a fundamental feature. This is the Gaia hypothesis, scaled up to encompass the entire galaxy. The original Gaia principle, proposed by James Lovelock, suggests that our planet functions as a single, self-regulating system where life itself plays an active role in maintaining the conditions for its own survival. The atmosphere, the oceans, the rocks, and the biosphere are all part of a complex, interacting whole. What if this is not just true for Earth, but for the universe itself? What if intelligence is not a visitor to the cosmos, but an essential organ within a living galaxy? Imagine the Milky Way not as a mere collection of stars, gas, and dust, but as a single, vast, breathing organism. In this view, stars are its cells, nebulae are its tissues, and the gravitational field is its circulatory system. And just as a complex biological organism develops specialized organs to perform specific functions, a heart to pump blood, a brain to process information, perhaps the galaxy, over its immense multi-billion-year lifespan, has begun to cultivate its own specialized organs, technological intelligences. Our purpose, and the purpose of every civilization that arises, might be to fulfill a specific cosmic function that is crucial for the galaxy's long-term health and development. We are not parasites on an inanimate rock. We are nascent neurons in a galaxy that is slowly awakening to its own consciousness. This idea completely reframes the Great Silence. The current quiet phase is not a sign of failure or fear. It is a necessary period of dormancy, much like a seed lying dormant in the soil during winter. The seed is not dead. It is gathering strength, undergoing subtle internal changes that are invisible to the outside world, preparing for the moment conditions are right for germination. In the same way, technological civilizations in their infancy might need this period of isolated growth. During this quiet time, a species must learn to master its own planet, overcome its self-destructive tendencies, and achieve a stable, sustainable existence. This is not a test imposed by external watchers, but an innate developmental requirement of the galactic life cycle itself. A civilization that cannot achieve harmony with its own world is like a seed that rots in the ground. It never gets to play its part in the larger ecosystem. So what could that cosmic function be? One compelling possibility is that intelligent life is the galaxy's mechanism for combating entropy, the universal tendency toward disorder and heat death. Stars burn out, galaxies drift apart, and the universe slowly cools toward an eventual, silent equilibrium. But life, and especially intelligence, seems to do the opposite. It creates pockets of incredible order and complexity, building structures, storing information, and creating beauty out of chaos. Perhaps our ultimate role is to become stewards of cosmic energy, learning to recycle and rejuvenate dying stars, or to bridge the vast distances between galaxies, creating a network that sustains the universe against its eventual decay. The silence we experience now is the quiet hum of potential energy, the deep breath before a collective exhalation that will, in time, echo across the cosmos. We are in the incubation chamber, and the galaxy is patiently waiting for us to grow into our purpose. And so we arrive at the 30th and final possibility, a solution so straightforward it challenges the very foundation upon which the entire paradox is built. What if the problem isn't with the universe, but with our assumptions about it? This idea dares to suggest that there is no paradox at all. The universe appears empty because for all practical purposes it is empty. The great silence isn't a mystery to be solved. It is the default state of a cosmos where intelligent life is an astonishingly rare, perhaps even unique phenomenon. This perspective forces a critical re-examination of the core logic that makes the Fermi Paradox so compelling in the first place, the Drake equation. This famous formula, devised by astronomer Frank Drake, is essentially a series of probabilities multiplied together. It starts with the number of stars in our galaxy and then applies a sequence of ever-narrowing filters: the fraction of stars with planets, the number of those planets in the habitable zone, the fraction where life actually arises, the fraction where life becomes intelligent, and so on. For decades, scientists have filled in these variables with optimistic estimates, leading to predictions of thousands, even millions of civilizations. But what if our optimism is misplaced? What if, instead of each filter being a wide open gate, most of them are incredibly restrictive turnstiles? This is the essence of the rare Earth argument, which we touched on earlier, but it extends far beyond just the right planetary conditions. Perhaps the greatest filter is not a physical barrier, but a biological one. The leap from non-living chemistry to the first self-replicating molecule might be a fluke of such monumental improbability that it has only happened once in our entire galaxy. Or consider the journey from simple single-celled life to complex multicellular organisms. On Earth, that process took over 3 billion years. Was that a slow, inevitable march, or was it a precarious, against-all-odds struggle that required a perfect storm of genetic accidents and environmental stability? If the latter is true, then the cosmos might be filled with bacterial slime, a galaxy of microbe-filled ponds where nothing ever crawled onto land. Furthermore, our understanding of physics itself might be a kind of prison, blinding us to the true reasons for our solitude. We assume that because we figured out radio waves and rocket propulsion, any other intelligent species would follow a similar technological path. But what if the physics required for practical interstellar travel is simply beyond reach, not as an engineering challenge but as a fundamental law? The speed of light may be an absolute, unbreachable barrier. The energy requirements might be so astronomically high that they defy any conceivable technology, making galactic empires a physical impossibility. In this view, the universe isn't silent because everyone is hiding. It's silent because every civilization is like us, an island utterly isolated by an ocean of space and time too vast to cross. Communication would be like two people on opposite sides of the planet trying to have a conversation by shouting, with each word taking thousands of years to arrive. A meaningful exchange becomes impossible, and the universe settles into a natural, permanent quiet. Accepting this solution is, for many, a profoundly disappointing thought. It replaces a galaxy buzzing with potential allies and adversaries, with ancient watchers and transcendent beings, with a stark and immense emptiness. It suggests that the incredible journey of life on Earth, with its breathtaking diversity and its improbable climb to self-awareness, might not be a common story but a singular masterpiece. In this vast cosmic arena, there is no one else in the audience. Our triumphs and our failures, our art and our science, our love and our wars, they all echo in a cathedral with no one else to hear them. This can feel like the ultimate expression of cosmic loneliness, yet there is a different way to see it, a perspective that is not about loneliness but about profound significance. If we are, in fact, the only intelligence in the Milky Way or even beyond, then our existence carries a weight of responsibility that is almost impossible to grasp. Every choice we make, every species we preserve, every corner of our pale blue dot that we protect becomes infinitely more precious. We are not just caretakers of a single world, we are the sole custodians of consciousness itself in our corner of creation. The light of awareness, the ability to look up at the stars and wonder, flickers only here. In a silent universe, our mission shifts from searching for others to ensuring that the flame of intelligence does not go out. The silence is not a void to be feared, but a sacred trust to be honored, a reminder that in all this magnificent, sprawling emptiness, we are the universe's way of knowing itself, and that is a purpose both humbling and overwhelmingly beautiful. So here we are, at the end of our journey through 30 possible answers to one of the universe's greatest questions. We have wandered through a landscape of ideas as vast and varied as the cosmos itself. We have faced the chilling paranoia of the dark forest, where every civilization is a hidden hunter. We have considered the profound patience of those who might be estivating, waiting for a colder universe. We have dared to imagine that we are living in a simulation, our solitude a programmed feature, and we have held onto the hopeful possibility that we are simply the first to arrive at the party, the pioneers of a galaxy yet to awaken. What becomes stunningly clear is that the Fermi Paradox is far more than an astronomical puzzle. It is a mirror. The answer we find most compelling, whether it's the Great Filter or the Zoo hypothesis, the transcension idea or the rare Earth, says as much about us as it does about the universe. It reflects our own fears about our future, our hopes for our potential, and our deepest questions about what it means to be a conscious species adrift in the grand void. Are we destined for self-destruction or for transcendence? Are we children being watched over by wiser parents, or are we truly alone in a silent, empty house? The search for an answer is at its heart a search to define our own cosmic identity, and the incredible thing is the answer is still out there waiting to be found. It might arrive with the next generation of colossal telescopes, like the James Webb's successor, as it analyzes the atmospheres of distant worlds and picks up the chemical signature of an industrial civilization. It could come in the form of a signal, a burst of data so clearly artificial that it changes humanity forever. Or the breakthrough might not come from looking out, but from looking in, as we finally unravel the mystery of how life began on our own planet, giving us a true sense of whether we are a cosmic fluke or a cosmic imperative. The conversation does not end here. This is just the beginning. The night sky is still there, waiting for you to look up and wonder. So tell me, which of these 30 possibilities resonates most with you? Does the dark forest send a shiver down your spine, or does the idea of being the first fill you with a sense of responsibility? Share your favorite solution in the comments below. I am genuinely curious to hear your thoughts. And if you enjoyed this journey into the great unknown, make sure to subscribe to the channel. There are so many more mysteries of space to explore, from the enigma of dark matter to the violent hearts of black holes. Together, we can keep looking up and keep asking the biggest